So this recording is for the AQA A-level Chemistry Paper 3, 2024, where I'll be talking through component 74053 and just specifically focusing on the multiple choice questions. I'm going to talk through each multiple choice question sort of step by step and how you would arrive to the answers. The likelihood if you're watching this video is just that you'd like to find out the answer to one or two specific questions. So in the description below, I've added timestamps so you can just scroll to the relevant question. So starting off with question 6, which row contains two species with different number of electrons? So you have NH3, nitrogen contains 7 electrons, 3 hydrogens, that'll be 10 electrons overall, and hydrogen fluoride, hydrogen has 1, fluorine has 9. So those electrons are the same. For the carbonate ion, you've got 6 for carbon, 3 lots of oxygen, that's 24 plus 6, and then you've got 2 extra electrons. That'll be 32 electrons for carbonate. For nitrate, you have 7 for nitrogen, 3 lots of oxygen, so that's 24 plus 7, plus the extra 1 for the 1 minus charge, so that's 32 as well. H3O plus, you've got 3 hydrogens, you've got 1 oxygen, and you've lost an electron because it has a positive charge. So that is 10 electrons in total. HF2, you've got 1 hydrogen, 2 fluorines, so that's 2 lots of 9, and you've lost 1 because it's got a 1 plus charge. So that would be 18 in total. So you can see these electrons are not the same. And just finishing off CH4, you've got 6 electrons for carbon, 4 for hydrogen, and that's the same 7 for nitrogen, plus the 2 hydrogens, plus an extra 1 for the negative charge. So again, C is the answer where the electrons are not the same. Question 7. Which element has the highest third ionization energy? So if it's third ionization energy, you've already lost 2 electrons. So we're considering how many protons compared to how many electrons there are. Now just looking through this list, I can automatically rule out C and D because they will have lots of shielding. There's a large distance between the nucleus and the outer electrons, so that would have very relatively low ionization energies. For A and B, so we've already removed 2 electrons. Lithium's got 3 protons. Beryllium's got 4 protons. Lithium, you've already removed 2 electrons, so there's only 1 electron left. Beryllium, you've already removed 2, so there's 2 electrons left. In both of these cases, there is no shielding. So the electrons are very close to the nucleus, and of course the atom with more protons would have a greater electrostatic attraction to that outer electron. So beryllium would have the highest third ionization energy. Question number 8. Compound P is converted to compound R via a 2-stage synthesis. Let's say you start with 100% of the atoms of P. Once you get to Q, you only have 50% of your atoms left. So you've got 50% yield. For simplicity, let's say you've got 100 moles to start with, you've now only got 50 moles left. When Q turns to R, you only get 30% yield in that second stage. So you had 50 moles in the second step, and you're only getting 30% of that left over. So basically, what is 30% of 50%? The answer would be A, 15% there. Question number 9. What is the formula of ammonium ethane dioate? So ammonium is NH4+, ethane dioate, you've come across that in transition metal chemistry. That's one of your bidentate ligands, also in redox titrations. So the formula of ammonium ethane dioate, you'd need two of those to cancel out one of those. So in this case, question 9, B would be the answer. Question 10. Which diagram shows the formation of a dative covalent bond? So a dative covalent bond is where one atom with a pair of electrons is able to share that pair of electrons with an atom with space in its orbitals. So A would be incorrect because nitrogen has a lone pair of electrons and it would share those electrons with a hydrogen ion that's got space because it's got no electrons. So A, the dative covalent bond, is the wrong way around. Similarly with option B, the nitrogen's got the lone pair, the boron has got 3 bonding pairs of electrons, there's space in its outer energy level to accept those electrons. So again, that dative covalent bond is the wrong way around. For C, oxygen has a lone pair of electrons, hydrogen has room to accept that pair of electrons, so C is the correct answer. And for D, once again, the nitrogen has the lone pair, so that would form coordinate bonds or dative covalent bonds with the silver. Those dative covalent bonds are the wrong way around. So just as a general rule, a lot of the coordinate bonds you'll come across is from an oxygen or a nitrogen lone pair pointing towards the thing that is able to accept a lone pair. Question 11. Which substance does not have any bond angles of 120 degrees? So remember, if it's got a bond angle of 120 degrees, it's going to have 3 bonding pairs and no lone pairs. So option A, you've got benzene. Each carbon forms 3 bonds. Spare electron becomes delocalized, so it's got 3 bonding pairs. The bond angles in benzene are 120 degrees. Boron trifluoride, boron is in group 3, it's formed 3 bonding pairs, and therefore that would also be 120 degrees. Cyclohexane. Each carbon has got 4 bonding pairs. Just remember, cyclohexane, all single bonds, C6H12. Each carbon is bonded to 2 other carbons and 2 other hydrogens. So in cyclohexane, all of the bond angles would be 109.5 degrees, tetrahedral shaped around each carbon. Graphite, similar to benzene, it forms these hexagonal structures. Each carbon forms 3 bonds with the spare electron, let's use that arrow there, with the spare electron becoming delocalized between layers. So graphite forms 120 degree bond angles as it forms these hexagonal layers. Again, only 3 bonding pairs, no lone pairs, because those electrons become delocalized. So all of the angles around the carbons in graphite would be 120 degrees. Question 12. Which molecule does not have a permanent dipole? So to have a permanent dipole, it needs to be asymmetrical. To be asymmetrical, it would either have a lone pair on the central atom, so like in ammonia, that would have a permanent dipole. Phosphorus in group 5 has formed 3 bonding pairs, got a lone pair left over, so it would have a permanent dipole. SCl2, sulfur is in group 6, it's formed 2 bonding pairs, it would have 2 lone pairs left over. Because it's asymmetric, it would have a permanent dipole. Silicon, which is in group 4, has formed 4 bonding pairs. It's got all of the same atoms around it, and there's no lone pairs left over. So because that's a symmetrical molecule, it's non-polar. It would not have a permanent dipole. So D is the correct answer for this one. Question 13, which one forms the greatest number of hydrogen bonds per molecule in the liquid state? So let's just eliminate a couple of the options here. So option B, got this thing called an ether, where the oxygen is just within the carbon chain essentially. Because there's no OH bond, there's no hydrogen bonds there. Similarly, with option C, you have an aldehyde. Because there's no OH bond, there would be no hydrogen bond. So B and C, not correct. So between D and A, which one has more hydrogen bonds? It is in fact carboxylic acid. You have the OH bond, so it can have hydrogen bonds between the O's and the H's, but also this lone pair can form hydrogen bonds with the H of an OH of another carboxylic acid. So you get more extensive hydrogen bonding because of the 2 oxygens in the carboxylic acid. You get less hydrogen bonding if it's an alcohol because there's only 1 OH in there. Again, A is the correct answer for question 13. Question 14. What is represented by the total area under the curve? So the total energy of the molecules, that would be incorrect. That would be the sum of all of the energies of all of the points as you go across. The total energy of reacting molecules, total number of molecules is the correct answer. This is essentially just a recall question. The area equals the total number of molecules. The total number of reacting molecules would just be the area to the right of the EA for option D. Question 15. What is the value closest to the rate of the reaction in centimeters cubed per second? So rate equals gradient in this case, and you need to find the gradient at 70 seconds. So you can see here I've drawn a tangent, find the gradient at this point, and the closest value we can see there is around 0.4 if you had to pick a couple of points on that line. So if you had to do difference in y over difference in x, you get a value of 0.4-ish centimeters cubed per second. Question 16. Which statement explains why the rate of reaction increases when a catalyst is added? So if you add a catalyst lowers the activation energy by providing an alternative route. Because the activation energy is lowered, we have more particles with energy greater than or equal to the activation energy. The particles themselves still have energy, the same energy, but the activation energy has been lowered. So you're not increasing the collision frequency. Particles aren't colliding more, they're just able to react when they collide. So the proportion of successful collisions increases because there's a decrease in activation energy. So again, they're not colliding more, it's just they're more successfully colliding. So C is the correct answer for that one. Question 17. A cell with the E value of plus 2.15 is made from 2 electrodes. Positive electrode, remember that is where reduction happens. and the negative electrode, that is where oxidation happens. So to calculate the E value for a cell, remember you do E reduction minus E oxidation. So the reduction is your more positive value, your oxidation is more negative. We're told what the E value is, the EMF, which is plus 2.15, and we're told that the negative electrode has a value of minus 0.46. So we're being asked to find the reduction potential for the positive electrode. So by using the values we're given, we're going to rearrange that equation to find X. And X in this case comes out as plus 1.69, which is option C. Question 18. KW. So remember what KW is. KW is the concentration of hydrogens, ions, multiplied by the concentration of hydroxide ions in solution. In pure water, this will also help us with this question, these two concentrations are the same. Because when water dissociates into its ions, and we've not added any external ions, these form in a 1-to-1 ratio. So let's go through each option. The concentration of hydroxide ions in water is 8 times 10 to the minus 8. So because Kw equals H plus times OH minus, and those two values are the same, we can say Kw is OH minus squared. So if we do the root of Kw in pure water to find the concentration of hydroxide ions, 18 degrees Celsius, so we're doing square root of that Kw value, the answer comes out as 8 times 10 to the minus 8. Let's just go through the other options to make sure you understand why B, C and D are incorrect. So the dissociation of water is endo or exothermic. So if we dissociate water, if we increase the temperature, we can see that Kw increases. So which way has equilibrium shifted? So at a higher temperature, we can see that Kw has increased, which means equilibrium has shifted right. If equilibrium shifted right at a higher temperature, that means the forward reaction must be endothermic, not exothermic. Because we have different Kw values at different temperatures, the pH values would be different. You can find the pH by doing minus log square root of Kw, and you'll see that the pH values are actually different in this case. Water does not become less acidic, does not become more acidic or less acidic at different temperatures, because in pure water these two concentrations are the same. It's still neutral, it just has a slightly different pH value. So again, A is correct, B, C and D are incorrect statements. Question number 19. As we go across the period from sodium along to chlorine, so sodium, magnesium, aluminium, silicon, and phosphorus, sulfur, chlorine. Just thinking about those trends, the atomic radius decreases across a period. So sodium would have the largest atomic radius. Does aluminium have the highest melting point? It's metallic bonding, got very high charge density in terms of its ions, so it would have very high melting point, but in fact silicon has the highest melting point because it's giant covalent. That statement is incorrect. Sulfur is the most electronegative. As you go across the period, electronegative increases, so chlorine is the most electronegative. Hopefully D is correct. What happens to ionization energies as you go across the period? They increase, with the exception of a couple of the atoms. So group 3 would be lower than expected. Group 6 is lower than expected, but chlorine does indeed have the highest first ionization energy out of these elements. Question number 20. Which statement correctly describes a trend down group 7 from chlorine to iodine? So what happens to the boiling point of HX as you go from HCl to HBr to HI? These are all polar molecules, so they've all got a permanent dipole-dipole, but the molecules are getting larger. So therefore you're getting stronger van der Waals forces between molecules. So HI would have the highest melting point out of those three. Notice we're not talking about hydrogen fluoride, which would have hydrogen bonding, but that would be highest. That's not part of the question. So A is the correct answer, because the van der Waals force strength between molecules increases. As you go down the group, HCl to HBr to HI, bond length increases. Distance between the nuclei increases. That means it's much easier to break those bonds. The bond dissociation enthalpy would decrease down the group. Statement C is a bit of a strange one. The standard electrode potential becomes more positive. So let's just compare chlorine so just inserting Cl instead of X with iodine. So linking this to the electrochemistry topic, a more positive E value means it's more likely to be reduced, or it is a stronger oxidizing agent. Which of those chemicals is more likely to be reduced? It would be chlorine. Got a smaller atomic radius, it's more likely to gain electrons, stronger electrostatic attraction. So as you go down the group, iodine is less likely to be reduced. The standard electrode potential would become more negative down the group. Again, quite a difficult sentence to understand and to interpret because it requires an understanding of the electrode potential topic as well. Statement D, what happens to the solubility of the silver halides? So hopefully you're aware silver chloride, the white precipitate, dissolves in dilute ammonia. Silver bromide, the cream precipitate, will only dissolve in concentrated ammonia. Silver iodide, the yellow precipitate, does not dissolve. So the solubility of silver halide in ammonia decreases down the group. So again, A is the only correct statement there. Question 21. So are chloride ions oxidized by concentrated sulfuric acid? No, they are not, because when you add chloride ions to sulfuric acid, you only form misty fumes, and it's not a redox reaction. Do they form a cream precipitate with silver nitrate? No, they form a white precipitate with silver nitrate. Cobalt, that's a transition metal. You should know that chloride ions in transition metals are very large, so you can only fit 4 of them around the transition metal complex. So chloride ions are very large, you'd only have 4 ligands around the transition metal complex. So therefore, that would be, 2 minus, apologies for the charge, that would be tetrahedral. That is a correct statement. Do they have the electron configuration 3p4? No, Cl- would have 18 electrons. It would end in 3p6, not 3p4. Question 22. Aluminium sulfate, when it's aqueous, is added to sodium carbonate. So this is one of the transition metal reactions you have to be aware of. So when it's aqueous, it exists as the hexa-aqua complex. If you add that to carbonate ions, you will see effervescence, because the hexa-aqua aluminium acts as an acid. Acid plus carbonate makes salt plus water plus CO2. You get a white precipitate because the acidic hexa-aqua complex would lose 3 hydrogen ions to become this neutral precipitate here. You might have remember learning this, where you've got 2 of the complex, 3 carbonates. 2, 3, and 3. So this is just one of the equations you had to learn from the metal aqua ions topic, and D is your correct answer there for question 22. Question 23. Correct structural formula. Let's break this down. Pentenoic acid. So we've got 5 carbons in a row. Carbon 1 must be COOH. Carbon 2, the En tells you there's a double bond there. On carbon 2, we also have a methyl group. On carbon 4, we have a chlorine. 1, 2, 3, 4. There's our chlorine. And then there's nothing on carbon 5 other than hydrogens. Add in the remaining hydrogens, and then breaking that down, we've got CH3, CHCl, CH, apologies, I put in an extra hydrogen there so we can get rid of that one because there's a double bond. C bracket CH3 coming off it, and then COOH. Then you look at the question and you work out which one it matches up to, which is C. Question 24. Which conversion does a nucleophile attack the organic reactant? You've come across 3 nucleophilic reactions. You've got nucleophilic substitution with haloalkanes. You've got nucleophilic addition with aldehydes or ketones. And you've got nucleophilic addition elimination with acyl chlorides or acid anhydrides. In all 3 of these cases, you've got a delta positive carbon that the nucleophile would attack. So in the first one, you've got an alkane going to a haloalkane. That would be free radical substitution. Second one, you've got an alkene going to a haloalkane. That would be electrophilic addition. C, you're going from an alcohol to an alkene. That one is elimination. And D, you've got an aldehyde going to a hydroxynitrile. So that would be nucleophilic addition. D is the correct answer. Compound Y has a structural formula, which we can see here. What compound is a position isomer of Y? So just remember, a position isomer is when you have the same functional group but in a different position. So we've got 6 carbons. The functional group is an ester. So a position isomer, it must still be an ester. So it can't be A and it can't be C. they would be functional group isomers instead. B and D are both esters. So which one is correct? So let's have a look at the ester that we're given in the question. So compound Y has this formula here. So that'd be 2-methyl propyl ethanoate. So it cannot be B because that's still an ethanoate. So what they've done from compound Y in the question, compound B, is they've given you a chain isomer, not a position isomer. D is correct because it's still an ester, but it's not the same. It's not just a chain isomer. They've just moved the position of the functional group. Question 26. Which one shows EZ isomerism? So we've got 4 different alkenes here. We've got A and B, which are but-1-ene and but-2-ene. If it's but-1-ene, we're going to have this. If it's but-2-ene, you've got a CH3 on each side. So I'm just drawing the carbon chains now. We'll add the methyl groups in a minute. For options C and D, we have pent-2-ene. So for pent-2-ene, we've got 5 carbons in a row. It doesn't matter whether I'm drawing E or the Z isomer. At this stage, I'm just drawing but-2-ene and pent-2-ene, and the first one's but-1-ene. So would A show EZ isomerism? If it's but-1-ene, on carbon 2 I've got a methyl group, and on carbon 3 I've got a methyl group. So I've just crossed out hydrogen. That would not show EZ isomerism because I've got 2 hydrogens on the same carbon. Option B, I've got a methyl group on carbon 2 and a methyl group on carbon 3. That would not show EZ isomerism because I've got the same thing actually on both of the carbons in the double bond. Option C, if I had a methyl group on carbon 2, so this is option C, 2-methyl pent-2-ene, you can see that there's 2 of the same group on one of the carbons in the double bond. That would not show EZ isomerism either. So now we're getting to option D. Hopefully this one's correct. So on carbon 3, which is this one here, I've got a methyl group. So this is 3-methyl pent-2-ene. I've got 2 different things on the left carbon in the double bond and 2 different things on the right carbon in the double bond. That would show EZ isomerism. Question 27. What's the product when this compound reacts with acidified KCN? So I've got butan-2-one with a methyl group on carbon 3. So this is the compound given in the question, and it's reacting with acidified KCN. So for the balanced equation, you'd add HCN in there. The cyanide acts as a nucleophile, joins onto the delta positive carbon. The double bond O becomes OH. So my overall compound, nucleophilic addition, would look something like this. When you have a nitrile group, the CN is carbon 1, and then you find your longest carbon chain. So what we have is 4 carbons in a row. That would be butane nitrile. On carbon 2, I've got a hydroxy group. On carbon 2 and 3, I've got some methyl groups. So it's 2 hydroxy, 2, 3, dimethyl butane nitrile. So that would be option A is the correct answer there. Question 28. Which statement concerning nylon 6,6 is correct? So this is one of the ones on the specification that you have to learn the monomers that make it up. Butane dioic acid is not one of the monomers. One of the monomers that does make it up is hexane dioic acid instead. It is not an addition polymer. It's formed via a condensation reaction, or it's a condensation polymer. Nylon 6,6 is a polyamide, so it can indeed be hydrolyzed by sodium hydroxide. It does undergo hydrolysis. So C is the correct answer there. All molecules of nylon 6,6 have the same relative molecular mass. Well, because it's a polymer, and the way that polymers form is actually you get polymers with different chain lengths. So the different polymer chain lengths would have different MRs. So that's why D is incorrect. Question 29. So which statement about the industrial production of ethanol from ethene at 300 degrees is correct? So this is the hydration of ethene to make ethanol. Remember, there's two methods to form ethanol that you need to learn. One is hydration, one is fermentation. If you add a catalyst, does that affect the position of equilibrium? It doesn't, so therefore the yield would not change. The catalyst would just increase the rate, it wouldn't increase the yield. This is a very fast reaction. Fermentation takes days, hydration takes seconds, so the reaction is faster than fermentation. The forward reaction is exothermic, so if we were to increase temperature and the forward reaction is exothermic, then the value of the equilibrium constant would decrease. The higher temperature would cause a lower value of A. And then option D, if we were to increase pressure, equilibrium shifts to the side with fewer moles of gas. So you've got 2 moles of gas on the left, 1 mole on the right. So higher pressure, equilibrium is going to shift right, and you would have a higher yield of ethanol. D is the correct answer there. Question 30. Which compound is formed by acid hydrolysis of phenyl benzene carboxylate? Just take a minute there, think about what that compound is. Benzene carboxylate. It's going to be an ester made up of a benzene ring from the alcohol and a benzene ring with a carboxylic acid group from the carboxylic acid. So if we were to acid hydrolyze that, you're going to make the alcohol, which would be phenol, and the carboxylic acid, which would be benzene carboxylic acid, or benzoic acid for short. So what compound is formed by the acid hydrolysis of an ester? You get your carboxylic acid and your alcohol. This is your carboxylic acid. Which type of polymer is most difficult to hydrolyze? So you can hydrolyze any of these because they have polar CO bonds, CONH bonds, whereas a polyalkene is often inert, it has non-polar bonds. Difficult to hydrolyze, it's non-biodegradable. So A is the correct answer for 31. Question 32. When do you have hydrogen bonding? It's not going to be the polyalkene, that's just your CH bonds, non-polar bonds. Polyamide, you've got lots of CONH bonds. Polychloroalkene, you've got CCl bonds in there, CH bonds. So you've got polar bonds, but no hydrogen bonds. And a polyester, you've got COO bonds in there. So which one would form hydrogen bonds out of a polyester or a polyamide? It's going to be the polyamide because you have the NH group in there, which is able to form hydrogen bonds. Oxygen alone cannot form hydrogen bonds because it still needs the oxygen to be bonded to a hydrogen. So B is the only correct answer. Question 33. Which structure shows a Zwitter ion of an amino acid? So a Zwitter ion has no overall charge. That's the important part of this question, because it's got a positive group and a negative group. So it cannot be B or A because the R groups also have a charge. R groups mean it's not neutral. So it has to be C or D. It's not C because there's no charge there, it's negative overall. But D is the correct answer because you have a positive NH3 and a negative CO-. That's your Zwitter ion. And the final two questions, you've got question 34 and 35. Question 34 was the hardest multi-choice question on the paper because there's quite a lot to break down here. So we have gas chromatography. We've got 4 isomers with the same formula. The carrier gas is nitrogen. So we have a non-polar mobile phase and a polar stationary phase. So in terms of retention time, the one that comes out first is the one that's going to be the least polar because it's got the highest affinity to the non-polar mobile phase. So the one that gets carried through by nitrogen is going to be the one that's most non-polar. Lowest retention time. The one that sticks to or has the highest affinity to the stationary phase would be the most polar. Highest retention time. So there's 4 compounds that are coming through here. And we're being asked which one is the most abundant. So the most abundant is this one, the one that comes out third. So the question is saying, okay, which one is most abundant? This one here. And which out of A, B, C, and D is going to be in order of polarity. So let's break it down. Which one is the least polar? So it's going to be C is the least polar because it's got a lot of symmetry in the molecule. You've got oxygens bonded to your CH3s. You've got 2 ether groups and an alkene. So C is the least polar. D has a bit less symmetry. Notice both of the ether groups are on the same side of the molecule. So D would be the second one to come out. So which one's most polar out of B and A? A's got 2 alcohol groups. That is your most polar structure. B has an ether group and an alcohol group. So we got there, B is the most abundant one. So again, really tricky question there. You need to understand about polarity, gas chromatography, and understand how to look at a structure and work out whether it's polar or not. And finally, question 35, which one is formed by pH 3 for this amino acid here? So at pH 3, that's a low pH, there is lots and lots of hydrogens, lots of H plus floating around. It's going to stick to any part of the molecule it can. So it would stick to the COOHs. It would also stick to the NH2s to become NH3+. It wouldn't be that one, that's a zwitterion, that would be neutral pH. That's wrong, you don't have NH2+, you have NH3+, so they're incorrect. So A is the correct answer there. So hopefully that was useful. Post the 2025 paper shortly. Thank you very much for listening.